Okay, so it says it's recording. Great. My name is Reshama Sheikh, and I am the founder of Data Umbrella. I am also an organizer for NYC Pi Ladies, and I am based out of New York City. Welcome to our session. The mission of Data Umbrella is to provide a welcoming and educational space for underrepresented persons in data science. We welcome allies to help us in our mission, and we welcome all different skill levels. We are on Twitter at Data Umbrella, so feel free to tweet and share about the event and follow us. Also, there's a LinkedIn page for us where I usually share job postings, so you're welcome to join there. And there's information on the website about a Discord for community. I just want to go over the code of conduct that, we're dedicated to providing harassment-free experience for everyone. Be kind to others, be professional and respectful. We really want to build a friendly community here. Our Twitter is, just to repeat, at Data Umbrella and also at NYC Pi Ladies. And this is our Meetup page. So I'll be posting any upcoming events on the Meetup page, even though this is webinar and it's available to anybody around the world. Its Meetup page is like the central page where events are posted. I want to thank our speaker, Shailvi Wakhlu, for joining from San Francisco. And I want to thank our sponsor for providing this webinar platform, which is Neo4j. And I'm just going to introduce Shailvi. I actually met Shailvi back in August in San Francisco when I was there for the Write Speak Code conference. Shailvi is the head of analytics at Komodo Health. And as an analytics professional and former software engineer, Shailvi has been involved in shaping great products for companies big and small for the last 13 plus years. She's worked on various analyses. Previously, she worked at Salesforce. And she, I guess the really impressive thing here is, additionally, is that she has worked with really large data at scale, 40 million plus users. So, okay. So, I'm going to get out of this. Okay, and then I think you should be able to screen share now.
Okay, perfect. Give me a second here. All right. Can you all see my screen? Hey, are you also able to see my screen?
Yes.
Okay, perfect. Okay, thank you. Yeah, all right. Anyways, thank you all so much for joining in today. My name is Shailvi Wakhlu. Thanks again, Reshama, for the introduction. And today I am going to walk you all through how I think that Sherlock Holmes would have fixed bad data. And I hope you're all as excited about investigating data anomalies as I am. So just a little bit about me. So this is me as a child. I used to spend a lot of time reading detective novels. And after I'd finished reading one, I used to go around hunting in my backyard for clues. I have no idea what mystery I was trying to solve, but one day I found this big, huge lemon. As you can see, it's almost the size of my face. And I didn't even know we had a lemon tree. So for my 11-year-old self, this was actually the most important discovery I had ever made at that point. And it just convinced me that I'm going to go on to do very exciting things in my future. And I do think I ended up doing some exciting things. I worked with a lot of different companies of different sizes, mostly in analytics, which I've been involved in for almost a decade. But even though I started as an engineer. And now I am the head of analytics at Komodo Health, where I lead a team of 8 data scientists. So today we're going to talk about 3 things. One, what is bad data? And why should you care about it? And how do we actually fix it? So, bad data is essentially, my definition is that it's inaccurate, incomplete, or misleading data. And essentially what that encompasses is anything that's wrong, anytime there's missing information, or there's duplicate information, but it's not actually tagged as such, or there's some information or data that's low quality, that's incorrectly transformed, that can imply something different than what it really means. All of that comes under the umbrella of bad data. Now, this is obviously just my definition. I'm sure what you really want is a scientific definition, and this is the best that I came up with. Bad data is anything that makes you want to throw your computer across the room because it just makes everything terrible. So I would like to call out that what bad data isn't is just if it's not something that you want to see, or if it's not something that you feel good about, like that doesn't make it bad data. It still has to fit the requirement of it being inaccurate in some way. And just because you don't like what it tells you doesn't make it bad. So with that distinction, let's actually walk through a couple of quick examples of how I think bad data actually manifests. So one of the most common things that I have seen is that, you're trying to pull up revenue numbers because revenue is important. And you have a Salesforce table that says you made $32 million last year. And you have an internal table that says you made $35 million. So automatically the question is, well, which one is right? And that $3 million gap, that is going to decide whether your company invests in more snacks for your kitchen, for example. So it's a really important thing to sort of solve for. And you want to make sure that you trust the data that you have. And if you don't trust it, like you have some caveats attached to it and things like that. The other really common thing that shows up is just, something where the analysis just looks really suspicious. So in this new chart, you can see that it shows you revenue by country, and it shows you have $25 million that you made in UK. And then you note that you're actually a company that's located in North America. You haven't even ever marketed in Europe. So all the North American countries make sense. So, who are all these people in UK who are buying your product? It just doesn't make sense that it would be the biggest country where you'd have revenue from. So things like this, they basically, are a starting point where you start wondering what's going on. And, what is this bad data? Like, where is all this information coming from? And the next logical question that comes up is, where is this bad data getting created in the first place? So for me, like the way I think about it, there's essentially a life cycle of data that has many phases, and each of those phases has some inherent risks that are associated with it where bad data can be introduced. So I know there's a lot of information on this slide, and I'm going to try to break it down. I put it as one visual because I actually personally have this printed out on my desk because I like to refer to it just to sort of fact check, any investigation that I'm struggling with. I try to make sure I'm covering my bases. So yeah, let me walk you through what's actually in here. So on the left, you see the 5 different phases of introducing bad data. So the first one that we start off is just the definition. This is where, the data team and the product team are reconciling, and they're saying, what are the features that we even want to consider as one coherent unit? And then what data requirements do we sort of associate it with it? After that, you go on to logging, where you actually translate some of those definitions that you had created in the previous step and turn them into actual code that you can use to log and store that data. After that, you are transforming that data in some way. And what you're essentially looking at is you're looking at your business rules, and you're applying those rules to that tracked data so that you can convert it into a format that actually makes sense, that is actually usable. After that comes the fun part. You're actually analyzing it. So data scientists typically, they have to interpret the data based on, actual business questions that they're trying to solve for. And that is where a lot of the action happens. And finally, after this, you actually share out your results. And it can happen in a bunch of different ways. It can happen in the way of an ad hoc analysis or some self-service reports, things like that. And all of these things are shared directly with stakeholders. So during all of these phases, I've on the right, I've kind of highlighted a few common things that I observe in each of the phases, like which are just according to me they're the most logical places where something goes wrong. So I actually look at all of these things just as a sanity check when I'm trying to investigate what happened. I'm going to walk you through a couple of them. I won't walk you through all, but because some of them I'll be discussing later when I'm talking about fixes. So, some of the most obvious ones or most common ones that I see is actually in the definition stage. So, when we think about features, anything that we are trying to track, it has some sort of a definition associated with it, and how we define that feature can make a lot of difference into what insights we're able to get from it at a later stage. So if you don't evenly apply the same sort of intention behind some of these feature definitions, it can get quite confusing later on. So an example here is that, let's say your product team says, I want to track all clicks on this page. Any click that happens, I want to track it. So that's it's a pretty all encompassing definition. But you also have a team that's dedicated to tracking things that occur on mobile. And so in mobile environment, they'll be like, yeah, I want to track the clicks there too. So initially you logically think that all my clicks on the website are being tracked, and some subset of them would have happened on the mobile. But if mobile team decides to not track all the clicks and only like 3 of the buttons that you can possibly click, then you have definitions that are not evenly aligned, because you'd assume that the website clicks are still kind of the superset of everything, but you'd expect that the mobile subset is a full subset for all mobile clicks, but it's actually only tracking three types of clicks. So that can cause issues, because anybody who's done this long enough knows that there'll always be that one person who'll say, I want that one click on mobile that nobody's tracking, like give me information on that. Like, you're giving me information about everything else, what about that one? So the more thoughtful you are upfront about like making sure you're tracking everything evenly, it'll just be easier in the long run. The other example is at the analysis phase. So, I think that's again one of the most common things that happen, that you just don't define the problem. It's very ambiguous, because especially when we're one human talking to another human, you're two separate humans, so you're always going to have some things where you're not aligned, where you don't understand each other. And if you're talking to a product manager, they can make certain assumptions that like, oh, I'm sure they already know this. And then you can make certain assumptions like, oh, I already, like, of course they know that this can't happen. So if you don't actually clarify some of those things, that can result in some very tough consequences. You may end up spending a lot of time doing some work which has to be redone because there was an incorrect assumption in the first place. Or worse, maybe the error never gets discovered because you're both calling it the same thing, but you're actually doing something that's completely different. So these type of examples, you can kind of look through the remaining ones later, but these are some common things that kind of show up. All right. So why should organizations or anybody even care about all this bad data now that we've seen a couple of ways it shows up? So I think inherently the big takeaway that I have seen over the years is that bad data is just costly. It's costly at every single level across the company. I think, to start with, the people who are working, who have to deal with it, it hampers their productivity if you don't upfront spend that time and effort in trying to keep things clean. And it affects their morale because they feel that, this is just, I spend so much time doing something I don't want to do. It can also it can cause liabilities. You can sometimes end up sharing information that you're not supposed to, or you shared incorrect information. That's especially a problem if if you're a publicly traded company and you had an earnings call where you said, I have, X number of monthly active users, and then the next earnings call, you're like, well, just kidding. It's actually 20% lower because I made a mistake. That's not going to look good, and your company might actually get sued for misleading shareholders. So bias, of course, is a big problem. If you have some data that's inherently biased and that's not known to you, like that's just it's a issue because it can cause harm to people based on whatever decisions are being made with that data. And overall, you can also just straight up lose revenue. So if you have a bad data pipeline and data goes missing, maybe your marketing team doesn't have leads to follow up on, and that can lead to material revenue costs. Overall, I think the biggest reason that I think this is important is also because it lowers trust. The minute your customers find out that there is something sketchy going on with your data, that can often be just game over for you, because if they don't trust your data, they don't inherently trust you. The one thing that I'd again like to sort of highlight a little bit more is that I think, besides all those other reasons which have a cost attached to it, I think just the fact that data scientists have low morale because of something like this is reason enough for people to care about it. Data scientists have to find the error, find the source, validate, cross-check. Like it's a lot of work that goes into resolving some of these issues. And I think inherently it very much is a part of a data scientist's job to do this, but inherently they feel, well, my skills are so much, there's so much other cool stuff that I can be doing. And so everyone wants their talents to be used in an optimal way. And you don't want people leaving a job just because they're always dealing with dirty data issues. So, cool. So next, how do we actually solve it? My thought here is, I think we solve it by thinking like Sherlock Holmes. And for those of you who are not familiar with him, Sherlock Holmes is a fictitious character created by Sir Arthur Conan Doyle. He is arguably one of the most famous fictional detectives, and there's a lot of books and movies about like that character. So check it out if you haven't had the chance to. So why did I actually pick Sherlock Holmes for, why did I pick that we should emulate his style? So I actually think that his style of solving crimes is very relevant to data scientists, even though hopefully we're not solving crimes, just data issues. But I think inherently we're doing investigations. And I think a lot of his personality traits are very good if you think of a philosophy of how data scientists should think. I think it's very relevant. And inherently, Sherlock Holmes is always presented as a very, very data-driven character. So I think his methodologies are actually extremely relevant. And the three sort of traits of his that I picked, which are sort of, larger bucketing of some of his personality, are deep observation, scientific method, and pattern matching. So let's dive into a little bit of each of these and see how they sort of manifest. So deep observation is, so there's a very famous quote that Sherlock Holmes says in one of the books. He says, you see, but you do not observe. And that's a very interesting distinction to call out, that it's essentially when we have data in front of us, our default is to look at it and absorb the information as is. But when we actually start observing it more closely, we gain more nuance by just interacting with that information as an active participant. And that is a skill that I think is worth building on. So some of the ways that you can build on that skill is to just be fully present and very mindful. So when you're mindfully interacting with not just the person who, your stakeholder, your your business partner, like people like that, like when you're mindfully interacting with them, you're more engaged, you are not going to be distracted, and that will mean that you don't miss out on something that's critical for you to be able to solve the problem at hand. And I think it's one of the best ways to have impact. The other way to improve your observation is to be an active participant with whatever you're doing. So, one of the one of the fun examples that they called out is that when Sherlock Holmes was given, they said, "Oh, here we found this note, and this is a clue." So he didn't actually just read it. He didn't just look at it. He actually smelt it too, because he said, smelling it is going to give me some extra insight that just reading it doesn't give me. And that is a very interesting thing, because you're actively participating with the information in front of you. You're being inclusive. You're not just saying, well, this is how I normally look at data, but like you're trying to be thoughtful and getting into the weeds of how you can use information to tell you different insights. The next thing, again, about improving your observation is to structure your thinking. So this one is, I think, like all good engineers have to do it. You have to just be structured. You have to keep good documentation. I think for data scientists, it's especially relevant because, sometimes during our analysis, we'll make some assumptions. And if it's not, or we'll make some decisions rather. And if it's not an intuitive decision, like why did we make that decision? Maybe we made it because we spoke to a colleague who pointed something out. And if 2 months later we'll forget why we decided to go this direction with our analysis, it'll be really helpful to you if you have actually sort of documented that somewhere, so that even you yourself are not struggling with figuring out why you did something specific. So and like being structured also means that you try to look at information and sift through it and say, like, let me step back and decide what is actually useful to me, what is just a red herring or something that's kind of taking me away from what I'm actually trying to do here. The next character trait was scientific method. And here again, the famous quote here is, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. It's a very scientific way of thinking about it, because we have to regard facts as truth even if we can't see it. And if the most likely answer is not the answer and the impossible answer is not the answer, we have to give the improbable answer a chance to prove itself. And we have to be truthful, saying that if this is where things are pointing me, I have to give it a shot to sort of see if that's actually true or not. So here again, you can build on this skill by just generally avoiding the trap of bias. And I think, a lot of times it's very easy, like it's human nature that if we're given something that makes our life easier. So if someone states an opinion which sounds kind of correct, like it makes our brain is programmed to just attach to it because it makes our life easier. So, but we should purposefully step away from that, because a lot of times opinions are stated as facts. And people, there must have been tons of companies that said, hey, our monthly active users just never go down, like we're a growing company. And then coronavirus hit, and of course a lot of companies lost users. And if they had treated that as a fact, that like there's just no way that we can ever have less people coming to our site, they would have just found it way harder to be like, well, why is this happening? Now, of course, in this example, I'm assuming people weren't living under a rock and they kind of heard about the COVID situation. So hopefully they would have been able to piece things together. But, there could be some situations where you just don't know what's going on. And the other thing here is, we tend to, the information that is available to us, like the information that's in front of us that we can see, we tend to weigh that more heavily than what we don't have access to. So for example, if I have access to the signups that occurred on my website, but I don't have access to the actual volume of people who came to my site and bounced out without signing up, I will just look at my signups and be like, yeah, it's going really well. I have so many people coming to my site. But the fact is, while that singularly might be true, if you just have had a lot more people come, and yes, overall your signups are going higher, but your rate of conversion is actually lowering, you're missing out on key information by like just being biased towards the information that's available to you at that point. And then the last way to build this skill is to regular science facts, like build a hypothesis, test it out. If you have multiple options to go with, rank them, pick the most likely one first to test out, and keep kind of validating each of them until you find something that fully explains what issues you might be having. The last skill was about pattern matching. So there is nothing more deceptive than an obvious fact, as Sherlock Holmes said, and it's because the interesting thing was Holmes was actually considered to be very good at understanding human behavior and predicting human behavior, even though he was considered someone who wasn't actually very good at empathizing. And that may seem not very aligned, but the sheer fact is that when you understand uh, situations, people, all of that better, you are much more easily able to find patterns, and you know that, hey, this may present as an obvious fact, but it's very common for people to sort of state it as a fact, but it's not true. So like, let me dig into it a little bit more. So a good way to improve on this skill is just to be very objective when you're trying to parse information. Understand the people that you're dealing with, understand their motivations, understand their fears. Those things could be very different than yours. So if you have stakeholders, if you have a product person and a marketing person who are both coming and telling you this data looks wrong, they might have very different opinions on where they think the problem occurs, and you have to still separate yourself from sort of those two conflicting directions, and pick what makes the most sense for you to investigate first, because otherwise you won't be objective and you won't stay focused on the truth. So yeah, as you hear opinions and ideas, like, it's always good to understand that also for future reference, but try to sort of like parse the right information from it. The last way to sort of improve on that skill is to just in general widen your knowledge base. So as a data scientist, I think it's extremely important that, like, obviously we have to get really good at understanding the data, appreciating what it does. But the other part is, like, if you do an equally good job at also understanding the product, understanding the users, understanding how your marketing channel works and things like that, it can actually allow you to make a hypothesis much more easily when you see things that are going wrong. And you'll be in a better position because you would have seen some odd things that happen, which if you were just focused on the data, you wouldn't have access to. So it basically allows you to consider factors outside of just what's in front of you. All right, so hopefully that all made sense so far. Now we are actually going to walk through an example. So we understand a little bit how Sherlock Holmes thinks and how we can apply his mindset to our own problem solving techniques. So now I'm going to walk through a simple example where we'll try to use some of those philosophies that I kind of just highlighted. And for the sake of simplicity, I am going to go with the assumption that we eventually have one warehouse where we store all our data, regardless of where it comes from. So whether it's initially coming from Salesforce, Heap, website logs, whatever, all of it comes and it sits in one data warehouse, because I want to make my life easier and just compare two data sets in the same place. So this is typically how the question starts, and I hope a lot of you can relate to this specific example, which is you have a colleague, maybe they're in marketing or something, and they come to you with a question. They say, the number of sales in May, I pulled one number from Salesforce report, and today they reported something else in all hands. And what's the deal? Why are they not matching? So obviously, a lot of things could have gone wrong. And for the purpose of this example, we are actually going to pretend everything that could go wrong did indeed go wrong. And yeah, I'll add that, of course, if you've been at a company for a while, or if you've interacted with that same data set for a long time, you'd probably start building out a good idea of where the problem might be. But for this example, I am going to assume that you just joined 2 hours ago. You know no one, you know nothing. All you know is your Snowflake warehouse password and what the offending data sets are. So before we begin actual coding, some simple sanity checklist to just examine the facts. We're talking about two different numbers. Basic questions. Are they even supposed to represent the same information? Sometimes numbers may be called the same thing, but they're actually not supposed to represent the same thing at all. So an example would be that, people may be just saying signups, but maybe the signups that are stored on Salesforce, on the Salesforce platform, are referring to signups that need a customer success person to reach out. Whereas the signups that would be stored in your internal table would be all signups ever. So, you're both calling it signups, but is it actually all signups and the same amount? The other thing to think about is, I think this is actually super, super common, but are they from the same time frame? And is your refresh cadence for the two places where you're looking for information similar? And that is, hands down, one of the most common things that happens, that one report could be set to begin at the first of the month, the other report is set for the first Monday of the month, or they're set to different time zones, just things like that. Like, they're all time frame related things. And those things, again, get it out of the way quick, because that is usually a very common reason for misalignment to occur. And the last thing here, sanity checklist wise, is just human error. There's, I think all of us, no matter how foolproof we make something, there's always going to be some unintended use. There could be some typos, there could be some extra filters. There's just basic things that are unintended, how you intention for them to be used. And then the last sort of checklist before we get into the coding is, just understand the data set and understand what the problem is before you fully dig in. So here, again, the basic questions to ask, what rules were each of the data sets built with? Is it just purely raw data and presented as is, or were there some transformations applied? Were there some business rules applied on top of it? A lot of this information is unfortunately tribal knowledge. And you, again, as a good data scientist and as a good citizen, you have to actually start documenting some of these things, so that other detectives have an easier time. And it's totally worth the time. The other common thing is the grain of the data set. So you could very often have something where, again, they look like they have the same number of columns, but maybe they're both aggregated at a completely different grain. And that could also result in some unintended things that you can't see. And finally, is there a pipeline issue? Again, that's also very common, that the pipeline just breaks for a couple of hours or something like that, and you're missing data from a specific chunk of time, or something weird is going on. So now let's, sorry, I just have some water. Okay. So now let's actually get into some code. So here's what our data set looks like. It has an ID column, and obviously there might be other columns as well, but these are the relevant ones we look at. There's an order date, there's a region, and there's a sales amount. And that's sort of the basic thing that we're dealing with. So the most obvious check to start with when you're comparing two different data sets to see what's going on with them, are they the same, are they not? After answering all those sanity checks that we just did, The first thing is, do they have the same number of rows? That can usually tell you a lot of what's going on. And so, the simple thing there is just select count from both of them, compare that number. Of course, you might decide to add like a where clause if you're looking for a specific month or a specific region or whatever the difference is showing up. But this is your absolute bare minimum starting point. After that, if they don't actually have the same number of rows, first thing is let's look for missing information. So in this example, the ID was a unique column. So we're basically going to look for, we're going to find the missing IDs, and we're going to say, whichever one, we're going to do a full join of the two tables. And if the ID is null in one of the tables, that's the table that it's missing from. So this, the second query should essentially give you a list of all the missing IDs and which table they're missing from. And once you have that information, we'll discuss a few different ways you can go about it, but that should give you some information. The next step, even if you did find some missing information, I think it's still, I think it's still useful to look for duplicates anyways, because again, pipelines do weird things and funky stuff can happen. So here again, you're simply, getting all the IDs, grouping the IDs to get a count. And you're basically looking for any ID that has a count greater than 1 from each table. And you're unioning those two subqueries and getting your final result that gives you the final answer. So this way, again, you'll have one result that will give you all the duplicate IDs that are missing, that are duplicates, and which table they're a duplicate in. So these queries that we have so far, like, of course, there could be a lot of like extra clauses that you could build into it, but just kind of sharing it as examples of like starting points of how to start even thinking about some of these issues. Next, and sort of the last SQL level check that I talk about is just doing a check at the dimension level. So here is where it gets very interesting and where your familiarity with the data can really help. But again, in this example, you're new to the company, so you have no idea what's going on. Once you've sort of eliminated some of the basic things, you want to start breaking things down by, one dimension at a time and seeing, is there a case where things are consistently off across dimensions? Or it's only one dimension where there's something gone wrong. So like, for example, in this query, I am looking essentially for regions where the region, the sales, the sum of the sales for a region in table 1 is different from the sum of the sales in region 2. And in table 2 for the same region. And this, so that's why I'm only doing like, it's only gonna result in the rows that have a difference. And that is immediately gonna tell me like, if I see all the regions, then the problem is either on a different dimension or there's something else going on. But if this data shows me that, only region that has a problem is say the East region or something, then that immediately tells me that the rest of my pipeline is probably fine, or my rest of my feature definition is fine, but at least I know to narrow down that I have to go do something about the East region, because that's where my problem is showing up. And like I said, like if all the regions are equally off, then you break it down by a different dimension. Maybe it's the product or something else. But the point is to keep doing those cuts until you find something where you have a step to dig further. So this is, these are obviously, this example has been simplified to sort of give you a taste of what this looks like. But I expect that people will, as they become more familiar with data sets, they will build their own scripts and write their own queries to resolve common problems. And I think, you should ideally make these things modular so that you can convert those code snippets easily and share them share them, save them, convert it into reusable modules so that you can like change things and kind of go around it. And you can also convert some of these things to visualizations to help you spot errors faster. So for example, like in my in one of the places I used to work at, like I had these scripts like just kind of ready to go because I always knew where the pipeline would break. And it was a different team that had to fix the pipeline. So I just had to provide them the proof that the pipeline is broken. So I had these scripts just ready to go. And when it wasn't a pipeline issue, when it was a feature definition issue, I would go through this because that was the most common thing. And then I would have something else to go through because I knew that, okay, for feature stuff, I write different scripts or I have different filters or something like that. And yeah, you can kind of like build on these as you get more comfortable with the data. So to wrap it up, I think one of the things to keep in mind is that as we saw through a bit of the examples, like prevention is a lot better than cure. And a lot of the sanity checks that we do before we do anything, before we look into stuff, like a lot of it comes into things that are easy to prevent if you do it in the beginning. So if you're, as a company, committed to reconciling on terminologies, documenting stuff, making sure everybody is data literate, it makes your life and everybody's life a whole lot easier. And I also think like automating stuff is extremely important. Like you should not have to do anything manually. If you're doing it more than once, then by all means be absolutely lazy and just do it once and never do it again and automate it. Because I think that actually allows you to be way more efficient in what's going on. The other thing is just simplify your curated data sets. So anything that has way too much information that you don't use is going to be very hard to debug when a problem occurs because you just have so many different things to look at. So keep it extremely simple, keep it aggregated to a level that you expect it to work at. And that way, also especially like at my company, we use Snowflake, which is super fast. But like, some of the old data warehouses, it takes a while to run some queries. So it makes sense if you have something that's simple and aggregated, so that you only go up one level if you've pinpointed the problem to like one section. And yeah, I think again, like it's very important to have an actual governance standard and some sort of a philosophy about who owns what, who owns which part getting broken, who's in charge of reporting things like that. I think are extremely required. And you should also have an audit process. So at some point you should do some kind of a quality or a data cleanup hackathon that is able to sort of address some of these issues. So yeah, I guess overall, like I think sort of wrapping up the philosophy and the methodology, like keep breaking down the problem into smaller parts until you are able to fully isolate where differences are occurring and bad data is creeping up. And the truth is out there somewhere. Like you just have to sort of like keep finding a way to get to it. And yeah, with that, I just wanted to leave you all with some additional research and reference material. I think there are some great thoughts that people shared about like bad data and also how to think like Sherlock Holmes, which you can apply for other things as well. And I also linked my own talk about thoughtful analytics in case anybody is interested. It is also on my website. And yeah, that's it for today. Thanks so much for attending. A special thank you for Reshama and Data Umbrella for hosting me. This is extremely fun. I haven't actually done a technical webinar ever, so this is it's all been in person. So this is kind of fun for me. I hope you all found the content useful. I will be taking some questions now, but also keep in mind that Data Umbrella is going to publish a recording of this on their website as well as on their YouTube channel. And I'll be doing the same as well in about a month's time. So, feel free to stay in touch with me on Twitter. And also, if you have any questions, I can answer them too right now.
Yeah, if you can hear me, right?
Yeah.
Great. Yeah, if anybody has any questions, if you just want to post it on chat, we have about 10 minutes left in the hour, so we could answer any questions.
Any questions or any observations? Anything else that you've noticed that helps you?
We have Renee Phillips here, who is like she's like very, very involved in Postgres Women SQL and in the conference, organizing the conference as well. And
Awesome.
Shailvi, do you want to put in the chat the link to the careers page for Komodo Health?
Yeah, let me quickly grab that.
That would be great.
There we go.
Thank you.
What's the hardest data quality problem I have faced? That's, to be very, very frank, it's so I'll go with the hardest one first. Honestly, it's convincing people that it's important, which should not be a thing. But I think some organizations have very good data hygiene, and they know sort of all the downstream issues that it can cause if you don't notice these things upfront. But I did work in an organization once where it was there was just absolutely, like, it was a wild west of like everybody just kind of do whatever and we'll figure it out later. And it was so costly because it took so many people so much time to try to, like, reset some of the things that were just very, very bad. And yeah, that was pretty hard. The most fun one, I would say, is yeah, I like investigating stuff. Like I like having an analysis that I trust. So if there's something that comes up which I'm confused, like, oh, why does this seem odd? Sometimes that entire investigation is because I think there's bad data, and maybe at the end of it I prove that it's not. Like, this is legitimately what our data is telling us. I think that's still a good outcome for me, because I think that whole process makes me understand the data a lot better, makes me trust different parts of it a lot better. So I do find it fun to have these challenges every once in a while, because I think it allows me to engage with things more. um, Ruchika asked, how do you take care of bias in the data when historically there has been a lot? So that's an interesting question. I guess my first question to that would be, like, how do you know there is bias, or is it just that you're trying to make sure that there is no bias? So yeah, Ruchika, I don't know if you had a specific sort of thing in mind, but I guess I'll just give you, I guess I'll just give you a general, making sure that there's no bias. Okay, yeah, I guess for me, I'm always trying to look at the use case. I think, whatever I'm trying to do, whatever I'm trying to get to as an answer, like, um, I think honestly, for me, it really comes down to talking to a lot of people and kind of almost poking holes at a problem. Like, what are the ways this could go wrong, where you know where we're doing something unintended. I actually, in one of the companies, I used to actually go and sit with the customer support teams occasionally and, like, get them to tell me, like, just show me examples of what people are complaining about our software. And that actually started an initiative where we would flag things which seemed like people just didn't trust something that was happening. Like, they didn't think it made sense. And some of those things were, I mean, there was, like, it was just, there was no reason for them to not trust it. But other things, like, it made sense, and we did actually do some investigations where we're like, yeah, the reason why this person said this looks suspicious makes sense, because there is something odd happening there that doesn't make sense. Melina, what tools do you use to clean up the data? So I think that for me depends on what I'm actually using. So I typically access most of my data in a SQL warehouse, and I end up doing a lot of it there. If I have exported it out, then I usually use R. But again, that's just my preference. My entire team is very much on the Python bandwagon, and that's what they use. Yeah. what additional functionality and unique capabilities does Snowflake provide? Oh, I have to tell you, I'm very biased towards Snowflake. I'm a huge Snowflake fangirl. When I was joining Komodo Health, actually, one of the first question I asked them is, "Do you have Snowflake?" And they said yes, and so I joined because my previous company did not have Snowflake, and I was very annoyed by that for the 2.5 years that I worked there. Snowflake is just really fast. It's such a it's I mean yeah, I'm like I said, I'm lazy. I like to spend less time doing stuff. So I was on Hadoop for a while, and those things used to take me like 20 minutes to run a query. And then in Snowflake, that same query would take less than a minute. So yeah, I'm not paid by them, but I do like their tool quite a bit.
I have a question for you. I was thinking when you're working with that many millions of records, do you often find those cases that are, just a handful that are problematic? And how do you, is it like finding a needle in a haystack, or is it something that really just sort of breaks all your programs because it's that exception?
Yeah, that's a great question. So some of the most like often that I did these investigations were actually at Salesforce, where the platform that I worked on had 340 million users. So it was obviously it was just a shit ton of data that was generated for the stuff that we were using. And that was the time I did not have Snowflake, so my queries would actually take longer. And there, like, that's the thing that I got to. Like, I think like we had a little bit of an understanding of, like, I think when I was at least able to explain, like, here's why this data is always going to be slightly shifted from this other data, then people have less of a problem. Like, if I've done that proof once, where it's like, we expect there to be a 1% difference when you're pulling it from this source versus this source, because they're out of sync, they're never going to be in sync, there's always going to be a little bit of lag here or something like that. Like, then if people understand it, they're okay with it. But if that shift ever like really changes, like suddenly even from 1% it goes to 1.5, like if it's crossed a threshold that we have established as a norm, then it warrants investigation. Like, what's going on? Like, is this something that's breaking, or is this really my data changing? And I think in that, like, again, the more time I spent with that data, the more sort of checks I built in. One thing I forgot to mention, but like some of these queries that I had put out, I actually got some of the data engineers to convert them into alerts, so that if some of those checks didn't pass, it would actually like things that I knew to be true, like I would have them coded into the thing, so that before that data was even published, it would go through all of those checks, and if something failed, it would not publish that data set, so that then I could go and look at it and be like, does this look fine or does this not? Does this require an extra investigation? And I think that was really helpful, because then you're not on a totally wild goose chase. You're actually, you're saying, like, here's what went wrong and here's what I'm going to do about it.
That's great. In pharma, we used to call those edit checks.
Yep.
I don't know if they call them the same thing.
Yeah.
Yeah.
Awesome.
Does we have another couple of minutes? Does anybody else have any questions?
Awesome. Great.
So thank you so much for joining us from San Francisco, right? That's where you are. I'm in New York, and the recording will be available soon. I'll send a message to the Meetup group. It's on our Data Umbrella events page, and Renee is asking if you would like to do a webinar for Postgres Women, New York City.
Yes, absolutely. Thank you.
All right. Thank you, everybody, and watch our Meetup page for upcoming events. Have a good night.
Awesome. Thank you so much. Thanks.
Bye.